Okay, good morning. Anybody from Tanzania? I guess not. Anybody been to Tanzania? Okay, many of you. Just wanted to give you just brief background on Tanzania as a context. We know that from a global data set and a lot of ex-ante analysis, the impact assessment from many different institutions. Tanzania has a lot of agricultural potential. It could be really self-sufficiency and food security and many of the potential benefits when they have adequate investment in agriculture. Currently, their productivity is really lagging behind other countries, and they have ambitious plan for next 20 years until 2020. They are going to be a major breadbasket of East Africa or Africa. So they defined a zone called a Seg-Cut corridor, including Southern Highland area, with a larger potential has been identified. It is about the size, just looking at the Tanzania part, about the size of Texas. So it's not a small land area, a large area with lots of diversity in it, but has been identified as a potential area. We were getting involved, our team at IFPRI are getting involved in a project called New Alliance for Food Security and Nutrition. It was an initiative set up by G8 a couple of years ago. And under this study, under this project, our team was charged to help African country government to set up efficient, effective plan, investment plan using geospatial targeting, ex-ante impact analysis to optimize where to invest on what, so that they can reach the food security goal that each government has been set up for Tanzania case by 2020. So that was our motivation. We are working with Tanzanian government and the partners working with Tanzania to see where to invest on what technologies. There are strong demand from the government side, of course, and a lot of studies have been done, and a lot of studies have been commissioned by Tanzanian government to see, okay, so what should we do, where to start? One of the kind of hallmark document is called TAFSIP, Tanzania Agriculture and Food Security Investment Plan, and they lay out a lot of ambitious plan for how to achieve the food security goal again. One of the first investment area they want to look at is in irrigation. They have 95 million hectare land area, about 45 hectares is suitable for agriculture, 7 million hectares has been suitable for irrigation already. However, only 1.3 million hectares are currently irrigated. So we did some consultation with the Tanzania stakeholder to see, okay, so what are the challenges for the investment in irrigation, and a lot of capacity building, low funding, and other external parts that they can't really control easily. But one of the key things always coming up is inadequate data. They just don't have good data to see where to focus that investment. So that was the demand, that was the motivation. IFPRI has been working on this area for many years, even before this. So we have dedicated group of people. You may not believe, but IFPRI has a water team running hydrology model connected to irrigation, the landscape irrigation, landscape water balance model, and linked all the way to the global scale trace model. We do have biophysical modeling capacity. We are looking at socio-economic factors. Irrigation potential assessment is particularly challenging compared to all other spectrum of technologies, because it cut across so many different sectors and different areas, socio-economic, institutional, and also other technologies, and even other sectors like livestock is also very related to irrigation. So you have to put really interdisciplinary researchers in a team to get reasonable assessment done. And and of course, because if there is currently so little area irrigated, where to irrigate is very difficult to answer at the very high resolution. You need to know what crops are currently under irrigation, but also which seasonality you have to assume, you have to know, and how do farmers cultivate irrigated crops. This is just a lot of assumptions also need to come when the farmers have irrigation, how they would do it. One of the studies IPRI published in 2010 looked at used this approach, this geospatial analysis for suitability and crop modeling and some cost-benefit analysis using economic modeling, and we published the study and published the data set. So it's one of the peer-reviewed articles out there, and data has been also used in many studies, other studies. However, the study was done in 2010 using a lot of data from 2000, so it's time to update, but just the same problem hasn't been really updated since. We talked with the authors of the team behind, a team of authors behind this study, and they were a little bit reluctant to say cutting out Tanzania from this African-wide study. Yeah, it's good for continental scale analysis, but I'm not sure how good that will be for subnational level. There's always this reluctance, and scenario set up in this study is all static. So when we want to use this analysis and talk with our national stakeholders, they want to explore some other options, some other data sets, and how things change. It's difficult to do that once you only have this printed, PDF printed article and static map. You need more than that. Harvest choice side, so we are developing a data platform using something called CEL5M. It's a 5 Archimedes 10-kilometer resolution grid across Sub-Saharan Africa. We developed a vector of data layers put together, and we don't just take other people's data together. We do our own analysis, spatial analysis, to disaggregate macro-level data and aggregate micro-level data to harmonize all the data intercomparable and interoperable at 10-kilometer resolution platform. Some of those data sets are funded and co-sponsored with GeoShare, and we really enjoy that community level discussion and engagement to update our data to more recent year and review at the community level. I will get to that a little bit later. Currently, we have about 400 of those indicators or layers in our database, and very different thematic area, biophysical, production side, socioeconomic side, and some market data. So we have all these layers of data that we give out to our partners so that they can do their own analysis. For this particular study, we used, this is a list of indicators we pull out from our database and use in the analysis. And those data sets, the GMIA, the irrigation map, and poverty mapping, subnational poverty mapping, updated with more recent data used with GeoShare contribution and sponsorship. And also some of the, SPAN 2005, we will get to that in the afternoon, but yes, SPAN 2005, we also very much enjoy the interactions with communities through GeoShare collaboration. So, okay, so I hope this works. So what we did was, we plot those indicators and developed a tool. Okay, so it doesn't, okay. I should have tested it on this computer. Okay, so I will get to the just screenshot of this. So we developed a web-based tool so that people don't need to have complex GIS software or a different kind of very sophisticated tool. So this web-based interface, we put together the relevant layers, and we gave a lot of options for people to, users to play around. This is a map of Tanzania focused on Seka corridor, and put together all this layer by layer, how they can move around, set their own kind of range of filters, so that I want to focus only on the area where depth to groundwater is shallow, so that they can easily reach the groundwater. I want to only focus on the area poverty rate is rather low, so they have more disposable income for infrastructure investment something. So there are these tools, and we are going to, by the way, put this tool on the hub so that everyone can play around this and see how things move around depending on the data set and the selection of the data set. And you can also see the contribution of GeoShare contributed data set, irrigated area, and poverty and spam data set, how the result changes with and without those considerations. So at the bottom, we are showing for each of the region at the district level how much area is falling under that criteria so that it's more suitable for the irrigation. So this is kind of geospatial scoping tool, giving flexibility on top of the IPRI analysis, which was rather static in the past, so that they can develop their own analysis on top of what we already had in the past. So that was a quick demonstration. Okay, so my last slide, concluding remarks. So this exercise and this study and this collaboration opened up a lot of opportunities and experiences. But we also have a lot of questions among ourselves. So, okay, so new data set from GeoShare, it was great. We were able to not only update our old data set, but also we took out some of the black box data set and processes and source code out of black box and shared with the research community, especially for spam, we will discuss in the afternoon. I completely agree with Navin's point that peer review is not enough. Peer review for publication goes only so far, especially for the data set. It takes a whole community involvement to make sure the data is relevant, data is suitable for whatever purpose people want to use. And the geospatial data set, so we are, as a researcher who generate the data, who is responsible responsible for those data sets coming up with our name on it, should even feel more pressure. I mean, I don't know how Navin sleep in the night. Your data is being used in so many different parts. You may not even realize how much policy implication you're bringing with your data set. Can we really stand by your data set? I heard from another IPRI researcher that saying, well, okay, so this is a map I generated from my analysis, but I don't think anybody will be making multi-million-dollar analysis using just this analysis alone. So that's why I kind of feel good about it. However, your analysis may be fitting into 10 different data sets, 10 different studies that will be fitting into another policy, important policy discussion. So we never really realize how important implication that you are bringing to this policy dimension. So yeah, a lot of pressure on you. And also, but however, this is difficult. So finding balance between a robust research framework on your lab and your office, but also making this available and making usable and user-friendliness, ensuring user-friendliness for capacity building and other people to use, because this is really the only way that you find problems, you find issues, or you identify where to improve your data set. Not easy, and that's why we wanted to develop this kind of web-based tool. It may look a little bit silly as a research output, but we thought it is really important to have validation through this way, inviting users to use your data, look at the data, play around the data layer by layer to see whether it makes sense or not. So yeah, and yeah, I just wanted to stop there, and yeah, we'll contribute to the discussion later. Okay.